properties, and you go to capabilities. You're looking for this one down in here, simplified remote restart capable. That's the one we're after. For the complex remote restart, this is one up in here, so don't get those too confused. If you only just find this one, then you don't have the simplified remote restart available to you. So how do you actually set this remote restart flag? Well, you can't do this at the OS, the VO server, or the HMC either interface, although it does look like you can in some places. You currently have to use the command line interface. Now, with newer versions of the HMC, we may have a graphical user interface to do this, but at the moment, not. We have to go to the command line. So I'm going to assume you know how to get to the hardware management console command line. You can SSH to it and use the same user and password as you can with the graphical user interface. So first then we're going to check with this command the list system configuration at the LPAR level. We give it the machine and the name of the LPAR we're wanting. So my practical worked example here is my machine is called P8 Lime and the virtual machine is called VM61. Lots of interesting information in here. If you've never been here before, you can find out the version of the operating system running and a whole load of setup details of the VM. This is the one we're not interested in here, the remote restart. This is the old complex one. We're looking for simplified remote restart. This is an example where it has been set already and the virtual machine has been restarted. It's remote restartable. If you're in here for the first time, this will be a 0 and there'll be something else in here, or not applicable or something like that in here. Another option is to do it for the same operation for the whole machine. So here we've got the name of the machine and we're saying limit the output to just the simplified remote restart capable and the name of the LPAR. And so we can see here all my partitions, including my VO servers in here. The only one that's set to capable is my VM61. Nice quick way of looking at whole machines at a time. If you want to set this is the command. We're going to change the system config, the name of the server, the name of the partition. Notice these double quotes in here, and we're going to set this one to a 1. It will be a 0 if it's off. And we can, if you want to disable this later on, we can do the same thing but with a 0. Now there is a warning here. The developers are very cautious, and they tell us that there is a CPU overhead of switching this on the HMC, as it regularly collects data from the VO server. I haven't seen it use any CPU time. I've only got some small machines. If you've got very large machines, something to be aware of. Perhaps you'd want to track your HMCs to see if the CPU consumption goes up. It's not doing this all this time. It's not a large overhead. It's doing it occasionally. Maybe when it's ready for you to change something on the VO server, it gets updated, or maybe you've changed the config on the HMC of an LPAR. Perhaps it then does a double check with the VO server to get the latest details. And once it's set, you can use the classic HMC graphical user interface. You can see it's activated down in here. This is the general properties of a virtual machine. On the new Enhanced Plus, we can see down here it has remote restart. Again, the general properties of a particular logical partition. This is the one that makes it look like you could set it, but it's greyed out. You can't actually click this button. Again, in future releases, maybe they'll make that available to us. Once you set that flag, don't forget you have to restart your virtual machine or your LPAR. Otherwise, this won't go into remote restartable, and that means that you cannot actually do the SSR. So next up, we'll do the validation to check that we'll actually be able to do remote restart if we want to. We can do this at the LPM level or the simplified remote restart level. We'll do both in this case, and you'll see that there's a bit of overlap in here. Okay, so we should know this already. Select your virtual machine from the HMC interface, operations, mobility. I prefer doing the validate directly without trying to do migrate. The migrate will actually do a validation check as it starts, so then you can then go on and do the migrate later. But let's do validate. This is a nice panel because it does ask you in one go what you want to do. So here we have the machine, the source machine, the virtual machine, and then in this button there's a pop down in here so you can select the machine you actually want to move it to. In this case we're going to the Emerald machine. Then you click the validate button, gives you a little pop up saying I'm getting on with this, and eventually comes up with either everything's okay, or in this case we've got some warnings. If you have errors, then it will not do the live partition mobility. Warnings though, you should have a look at the details in here. In this example it's saying the target machine doesn't support hardware accelerated active memory expansion. And that's okay if we actually using it at all, but it means that we'll have to use the software acceleration of active memory expansion. That will work quite happily. Anyway, the bottom two down in here, regarding these complaining, the 4CCs, we see these all the time, it's saying the slot numbers it's using on the target machine are actually, that it wants to use, are actually already in use, so it'll have to use a different slot number. I'm sorry, I can't get excited about maintaining slot numbers. My brain's got better things to do, so again, I'm happy that the slot numbers will be changed. So then let's do the validation via the simplified remote restart. So we go back to the HMC command line interface, and this is the command that we're going to use to do the validate. This is the command we actually use to do the remote restart as well. Somebody who wasn't quite thinking about this is remote restart start LPAR. Source box, the LPAR that we're going to move, and the target box. Same sort of parameters as we had in the graphical user interface. So here's my worked example. Here's my source machine, my virtual machine, and my target machine. And oh look, those are the same error messages that we saw before. Yes, it is doing a check just like the live partition mobility, so you don't have to do both of these tests really. The nice thing is that the start LPAR command does a live partition mobility validate, but it also does some other things like checking that the remote restart flag is set and that you're in restartable mode, otherwise it will give you error messages, as you can see down in here. It might check other things, I have no idea, but it's probably worth doing just this one if you're going to do one or the other. Now here's the syntax for this remote restart start LPAR command. We've looked at validate, we'll look at restart in a second when we actually do it. There's a cleanup operation in here. We have the manage and target machines, and we can use partition name or a partition ID if we want. There's a whole bunch of options which were used for the complicated restart. There's a couple at the bottom that you may want to have a little fiddle with, but you can read up in the manual pages to actually find out more information about those. These are the official prerequisites. Some of these we've covered before, so I'll whiz through those. But have the same network and disks, of course. We have to have at least 820 HMC matching firmware, but I'd recommend 840 or later if that's available by the time you're watching this video. The machines must be remote restart capable. We've covered that already. Both machines must be managed by the same HMC. That's beyond the requirements for live partition mobility. It could have two HMCs involved. Another important one is the HMC must have a connection to the service processor. The service processor must be actually available, powered up and running. This is a very important check because it needs to know that the box is powered off, so it knows that the LPAR is not running. If it can't make that check, it is extremely worried that perhaps the network to the service processor is broken. And if it does the remote restart, you could end up with two LPARs talking to the same disks. That is catastrophic for your file system. It would immediately, very quickly, trash your file systems, and you'd have to reach for a tape to work around that. Also, that the source machine must be in one of these modes, error, power, or error dump in progress state for the remote restart to work. Fortunately, if you power off the machine at the HMC, you end up in power off mode, so you can do a passive test of this. We'll look at that in a minute. At the LPAR level, then we must have the restart capable switched on, and we must have restarted the virtual machine so we're in a remote restartable state. Officially, at the time this came out, it didn't support the shared storage pools. I'm a big fan of that, so I've been working with the shared storage pools. It works fine for me, but officially that is not supported. Worth checking if you want to use the shared storage pool. Now let's pretend that we actually got down, bang, machine exploded, or something disastrous happened to it, powered itself off. It's sitting there in the computer room. Well, we go back to the HMC command line interface, and we run the same command we did for the validate, but this time we're going to use restart in here. Alternatively, if your machine names and your virtual machine names are big, long, complicated hexadecimal numbers, very easy to get wrong, perhaps you'd actually want to define on the HMC some variables, then you can use the variables in here, or if you're scripting, that might be a good way of running to make sure you get the right machine and the right virtual machine over to the right target. This works just fine, like live partition mobility, you can go to the HMC and watch it go through the various phases of creating the LPAR, setting up the resources, talking to the VO server to connect up the right networks of disks, and then restarting it. Because it's not having to move memory, the machine is down, there is no memory to move over, it's nice and quick, and it automatically restarts the virtual machine on the other end, at the end of the live partition mobility for you. So this is really nice, works very well. Now, I was going to actually capture a movie of it actually happening. My little LPAR here actually happens so fast, there's barely anything you can recognise. You see a couple of codes changing on the HMC and it starts up. If you had a very big, perhaps a big database or something with many disks and many networks attached, it will take a little bit longer to configure it up. But it's essentially exactly the same as you get with live partition mobility, so we'll skip that. Now, there is something to bear in mind, that we have some debris on the source machine. The machine is down, so we can't delete the LPAR like live partition mobility do on the source machine. It's not possible. It was powered off, so we can't actually change the details of the LPARs, and the VO server was shut down, so we can't do that part either. Now, if we did try to do that, and we just ran the command to do the cleanup operation, and the machine was down, we get an error message saying the machine is not in the right state, we need to power it on. If we then tried it again and the VO servers aren't running, it will say, no, we can't do that because the VO servers aren't there, I need to communicate to those to detach the resources to the LPAR we're trying to delete. If you power up the machine and start up the VO servers and let it settle down, give it a couple of minutes, then you do the cleanup operation. In my case, my small LPAR, it took a couple of seconds to actually do that operation. If it's much bigger, it may take 10 or 20 seconds to actually do that operation. Then we're in a nice clean state. The machine that is actually down, we've moved the LPAR off, and the LPAR isn't on the original machine anymore. Now, you might think at that point we're all done, we've covered it, and if you just wanted to see how it operates, then that's okay. There's a couple of other things I want to go through. One is, how would we actually test it's going to work properly in advance of it actually happening, and we've got to do some preparation for when it happens, particularly for large machines with lots of LPARs and lots of possible targets. So let's think about testing. A couple of little things you may not be aware of. Assuming everything's set up nicely, we need to get to the power off state. We can do that business as usual, shut down the virtual machines, shut down the VO servers, and shut down the machine on the HMC. That gets us to power off and ready for our testing. Some people may say, hang on, that's cheating a little bit, isn't it? Because you've done an orderly shutdown, everything was flushed, the business stopped. In an emergency, it's going to be a much messier shutdown than that. Well, there's a couple of things you could try if you really want to. You could yank out the power cords. We need to talk to the service processor, so you have to push the power cords back in, and make sure you haven't got auto restart set up, so that it doesn't start up the virtual I/O servers and start up the virtual machine again. That's a warning there. If you've ended up with the HMC to service processor network unplugged, the HMC will just see the machine as unknown, and that won't be available for a simplified remote restart. You could just, without shutting down the VO servers and the virtual machines, just power off the server. And as far as I'm aware, that does a fairly nasty immediate shutdown of the machine without giving the VO servers and the VM a chance to clean up. That's another way of doing it, up to you which you go for. Then, as we've seen, you can do the RR start LPAR restart command. This should return fairly quickly, and you can watch that as you take over onto the target machine. Be ready with that. If you have to log into the HMC, it will be done by the time you get to the right screen, and it will start up the virtual machine automatically. Don't forget, if it fails, you have to do this RR start LPAR recover command. We haven't really covered that. The problem is, I've never found it failing at that point. But do remember, the recover, if it does fail to actually do the restart, you can do a recovery, in which case it will then try and put it back to the original machine. Hopefully you can either retry the remote restart, or you can actually get the original machine up and running and just run it as normal on its home machine. Don't forget, after you've seen the remote restart work, then you'd want to start your machine, start your VO servers, let it settle down, and then use the cleanup command to remove the original source LPAR. Now there is another way. If you set everything up as we did before, but instead of actually invoking the remote restart on the HMC command line interface, we can actually do that in the PowerVC graphical user interface. The button you're looking for here is the remotely restart virtual machines. This appears or becomes ungrayed out when you actually click on a powered off host machine that is ready to do the remote restart. The prerequisites for this are a little bit higher than the base SRR itself. I recommend there, of course, go to the latest VC and the latest VO servers and the latest firmware and HMC. Now here we go then, we clicked on a particular machine. Here's our old line machine again, it's in the powered off state, and we can see the button over here. We click on that to actually activate the things. It says, well, in this case this is the only LPAR that is ready for remote restart, so we can select our LPAR and then do the remote restart operation. It then says, well, where do you want to go, and it gives you a list of the compatible machines where it could be moved to. You select your host machine and click on the remote restart. And then, typical of PowerVC, it throws that into the background. It gives you a little message that will get back to you when it's actually happened. On the screen you can see there it's rebuilding, it's doing the same sort of thing, and again it's a bit of an anticlimax. It doesn't take very long to actually rebuild it and start it up on the target machine. Now PowerVC does a little bit of housekeeping for you. On the original machine it would check every 2 minutes, I've been told, that if once the machine is up and the VOs are started, and it will automatically do the cleanup operation for you. You don't have to log on and sort that out yourself. I quite often get asked, is this like PowerHA? Basically on the cheap, that's great, we don't have to buy PowerHA. Well, let's make a few observations on that. This is classic PowerHA or HACMP, as they call it. We have a working machine in here connected to the disks. It's busy working on here. If we have an incident of many types, but it just means the working machine is gone, then the standby machine over its heartbeat will say, okay, the other guy's gone, I'll take over the disks and I'll restart the application on those disks. Does that completely automatically, completely regardless of HMCs or service processors involved in here. If we look at the alternative now with remote restart, of course we have lots of LPARs here rather than a single pair, and the HMC is controlling all this. If it's in the right conditions, then it says, detects that the machine is down, then you can manually decide to do the remote restarts. But first of all, of course, it has to build the logical partition and pass the disks over to these newly built logical partitions. There's no warm standby in here. The application then has to do a cold reboot of the operating system, recover the disks and restart the application. So quite different scenarios. I've got a sort of hit list in here of the various points of PowerHA as opposed to remote restart. In the PowerHA, these first 5 conditions, application fail, X fail, the virtual machine has failed, or the whole machine is powered off or dead, those will all be acted on by PowerHA by the warm standby. In the remote restart case, a lot of these won't actually be noticed. If the VM fails, we could actually manually do a static partition migration ourselves, if you spotted that. The one that it does cover here is number 4, the whole machine has failed and powered off, in which case then we get notified that remote restart is possible, and then we can manually go and do that operation. A whole load of red in here are things that are very different or not supported with remote restart. I'm just leaving this with you on the slide for a second so that you can have a look at, compare and contrast these two things. It really reminds us how powerful PowerHA is in what it can do and achieve for us for automating recovery from many sorts of problems. We have been talking about fairly simple cases with low number of machines and low numbers of virtual machines, and life's not going to be too bad. The setup, if we have LPM working already, it's fairly easy. The noting the crash, then the HMC will definitely notice. You can get it to email you, for example, or some other alerting tool warning everybody that the machine's down. We have to take some action. Then you'll have to go through a loop, first of all finding which is the most important virtual machines to get up and running first. Then you have to select some target of where it can go, spare capacity, or perhaps you'll have to switch off some virtual machines and tell the guys using the test virtual machines that they're not important and production takes precedence and knock them down. And then you'll have to be running the SSR, maybe you've got some script to make sure you actually move the right LPAR to the right machine to actually get the work done. Now if you've got some hand-driven operators doing this operation, then they will be told of the machine failure, they'll get out the manual, look at the procedure and start the recovery of the production virtual machines as soon as possible. First of all, they'll check the server is actually still down, it wasn't some transitory problem of the machine is actually coming up, best just to let it recover and start the workload again. Then they'll be running the commands to actually restart the LPARs on the selected virtual machines, maybe in a sort of priority order to the selected resources. Now, this works okay, but small cases, but if you've got real big computer rooms, many machines, maybe it's an enterprise style machine and 1,000 LPARs have gone down. Imagine having 10 operators and they all got 100 LPARs they're trying to restart. It could be fairly chaotic. So perhaps we should sort of automate this with some scripts. We can use a remote login to the HMC to detect the machine has gone down for enough of a period of time that we think we have to take some action, and then it goes through a list selecting the virtual machines and the target resources to go off and use. Of course, there's some big complications in an automated tool. How to update this, for example, if you're using live partition mobility, the script has to notice that the database isn't on the crash machine anymore, it's on somewhere else, so we don't have to move it. Perhaps we occasionally want to shut down a machine for maintenance or upgrade, and so we don't want it to kick in while we're doing that operation. What happens if we have two machines fail and we're trying to then move a virtual machine from a failed machine, but the target is the actual one that went down as well? We get into a right old mess in here with mutual dependencies. So this isn't going to really scale very well to hundreds or maybe thousands of virtual machines. Well, the developers thought about this and they came up with a script, RRMonitor. This will give it a source and a target, an LPAR name and an interval of how fast to actually take actions, and it will monitor that particular machine and LPAR and move it if required. There's a little bit of a limitation here that there's one script per LPAR, so if you have 1,000 of them, you have 1,000 of these scripts running. Of course, they're not running on a sort of local basis, they're just coming in again to make their checks. I'm also told that the script does have to run on the HMC, which is normally banned. The HMC is locked down, you're not allowed normally to run scripts on the HMC, so you have to do that remotely. Now, fortunately, our Tripwire 666 expert, Benoit, modified the script so that it can run as a remote command from another machine, and it logs onto the HMC to actually do its work. And we have a download link. Okay, we're about done. Simplified remote restart. Set up on the HMC and then controlled with HMC or PowerVC. Similar to configure as pure virtual machines, and you will start that requires a power 8. Here's the virtual machine that I wouldn't recommend. The latest version. Exit, get out the jailbreak code, because you have to rebuild by hand all parts and connect to this new version. And this requires a network. So if you're blue discs are available on the mirror set, and we can just carry on running our machines and our virtual machines without interruption. Then if we get our discs selected and our SAN connection, then the shared storage pool will realise that the other set of buttons are now available, and it will automatically resilver back to those buttons so that we have the full mirror version of our shared storage pool. We don't end up with stale drives where we have to log on to our virtual machines to actually do the resilver, which is good news. That saves a lot of manpower when we have hundreds of virtual machines. For what happens now if we lose our server and our disk system at the same time? Instead of thinking of these two machines and the disks in a single computer room, perhaps they're different ends of a large computer room, or they're in two different computer rooms in the same building, or nearby buildings. We have high-speed cables merging between the two buildings. So in this case, we've actually lost a building or a computer room. Well, of course, the damage is high, but what can we do about it? Shared storage pool. Well, we've lost that mirror. We carry on the remaining mirror. We could rebuild that virtual machine on our existing kit. We could edit here, remount virtual units into our new virtual machine and carry on running. We have other movies that go into this scenario. This shouldn't take too long. Simply reboot the virtual machine virtual units. Automatic rebuild. Look at the other movies for information. If we then get back our disk selector, then the remaining part of the shared storage pool will do the automatic resilvering until we're back to our mirror condition, which is good. If we then get back our server, well, now we have to be careful because we have two copies of the virtual machine sharing one copy of disks, and we know that can't work. Well, we're going to try loading crashes your file systems as you go, and so badly that you probably have to go for backup testing. It's been out for a year and a half to 2 years now, business as usual. While the new VM is running, do not restart the server, the old server, if it will restart the old virtual machine automatically, and certainly don't restart the old virtual machine manually. You have two approaches. You could remove the old virtual machine and then use live partition mobility to take the new machine back to the old server if that's where you want to run it. Or you could shut down the new virtual machine, then restart the old virtual machine, and then to clean up you want to delete the new virtual machine to stop yourself having an accident. As I said, this is all business as usual. We've had this for a number of years now. Let's look at some new possibilities with this DR offering. So let's talk about proper disaster recovery. We have a whole site down, the servers and the disks have gone, and of course you are stuffed at this point unless you've prepared for this scenario and you've done some homework and at least got your data out of the computer room somewhere else. This could be water or fire or flood, all sorts of reasons. Most probably some digger cut up the electrical power supply and your generator failed to start. So what do you need to do in advance so that you can recover from your disaster? Well, most disk units have some sort of point-in-time remote copy